As we continue to talk about geometric transformations, we're going to talk about translations, and translations are a rigid transformation. But before we get into some definitions, what we want to be able to do right here is we want to be able to develop the definition of a translation using constructions, write a rule that describes a given translation, and determine the image or pre-image of a figure after a given translation. So, dealing with the translation, let's start with transformations. Now, transformation is a one-to-one mapping of all points of one figure to another figure. Now, a rigid transformation, though, also sometimes referred to as isometric, that is a transformation that preserves the size, length, shape, and lines and angles of a figure. So rigid means it's going to stay, or the same shape, same size as it is moved about. And then finally, the translation. That translation is a rigid transformation that moves every point of the pre-image of an object the same distance and direction to create the new image. So that is the translation. It is the same direction, everything moves the same amount. And just as a reminder, those transformations, we're looking at a dilation, which is a transformation but not a rigid transformation. And then my rigid transformations will be a reflection, a translation, and a rotation. So in that reflection, I may have an object over here that is reflected over the axis. I may have one that is on the coordinate plane. Maybe it starts here and then it is rotated and ends up over here. So that is a rotation. And then the translation is I may start with an item right here, and then it is going to be slid this direction, and it's going to end up over here and it going one direction. So those are quickly the rigid transformations. And then we talk about the translation properties. Well, one thing we know that what does it preserve? And if it preserves its shape, so it's going to keep the same angles, the angle measure. It's also going to keep the same lengths. It will keep the same shape, and then the same size, and also the orientation. For example, during a rotation, the orientation is going to change. So those are things that you have to keep in mind here. So if I translate this, it will translate this direction, keeping its orientation. So if I have A, B, C, D, my new image for my pre-image would be A1, B1, C1, D1. It would not be a translation if I have A, B, C, D, and then when I translated it, my new translation is A, B, C, D. The orientation has not remained. It has actually been flipped. So just keep that in mind, that it's going to maintain its same orientation. And we talk about the notation. Okay, so a translation is, we're going to start off somewhere on the coordinate plane in this case, and we're going to start off at x, y value. That's my input. That's where my starting point's at, my pre-image, if you want to say it that way. And then our output is going to be following a translation. So the notation would be x plus a, and then y plus b. And a is going to be your horizontal shift, up and down. And then b is going to be your side to side. Did I just get that wrong? I absolutely did. So b, the y value, is going to be your up and down. And then your x value, it only makes sense, is going to be your side to side. Okay, so, and then how do we write that function rule? Well, right here, the function rule is T, standing for translation AB. That is going to be the amount that you translate both your X value and your Y value, and then will be your ordered pair of your start. So if we look at this, I'm sorry, when I say start, from your pre-image, and we'll look at some mapping. So as we look here, this example is going to be, what is the image of triangle JKL after the transformation of, let's see here, this is my XY value. As I transform, it's going to be X plus 2, and then Y minus 4. So if I look here at my image, if I have X plus 2, so if I start here, I go over 2. Start here, I go over 2. Because I'm going to positive 2, I go over 2. And then it's telling me that my Y value is going to be negative 4, so I'm going to go down 4. 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2, 3, 4. So it looks like my new image is going to be right here. So this is going to be L1, J1, K1. So there is my new image from my pre-image. And then how would you write that? Let's go ahead and look at that from a mathematical perspective and just instead of from graphing. So if I look at my pre-image, J is going to be negative 2, 1. And now my mapping here, we ended up having X was plus 2 and Y was minus 4. So my new image can be my image versus my pre-image. I may have J is going to be, J1 is going to be negative 2 plus 2, right? Because that's going to be my translation. And then Y is going to be 1, right? Minus 4, because that was my translation here. So that should be J prime is going to be equal to, the X value is going to be 0, and the Y value is going to be negative 3. And if we look over here, sure enough, I look for my J. J is going to be, the coordinate right there is going to be, I better not use that color. That is going to be 0, negative 3. So I can actually do just algebraic mapping instead of doing it on a coordinate plane. Now the rules here, writing a rule again, I am looking for something that is going to be X, Y, and then X plus or minus some value, and then Y plus or minus some value. So writing a rule, and I'm going to start off here with L, M, and P. And we're going to, again, it's a translation, so my orientation stays the same. And in order to write this, to get to figure 1, it looks like my X value is going to go negative 1, 2, 3. And then my Y value is going to go positive 1, 2, 3, 4, 5. So that rule should be X minus 3, Y plus 5, because that is how far I went back. 1, 2, 3. Then went up 1, 2, 3, 4, 5. So this is L1. This is M1, N1, and then P1. So that is that transformation to get to there. Now, if I look at figure 3, my X value again has gone up 1, 2, 3. So as I go from M, 1, 2, 3 will get me, and then I go, so let's see here, I have X, Y, and then I'm going to have X, and I have Y Well, we said y goes up 1, 2, 3, so that's going to be y plus 3. And then my x value has moved right 1, 2, 3, 4, 5. So it's going to be x plus 5 because going right is positive direction. If I look here, my next figure, figure number 4, it has actually shifted the x value the same amount. And then the y value is going to be shifting down 1, 2, 3. So it looks like I have xy. So my x value is plus 5, right? That's my translation. And then my y value is going to be minus 3 instead of a positive 3. And looking at figure number 2, looks like we have come down 1, 2, 3, 4, 5. So my y value is down 5. Y is minus 5. And then my x value is going to be 1, 2, 3. X minus 3, y minus 5 would be that rule that we were looking at to get these points. Now, looking at this example, it says Randy draws triangle ABC on the coordinate plane with vertices A is 7, 4, B is 10, 3, and C is 6, 1. Then he translates the figure, so the coordinates of the image are A1 is going to be 5, 1, B1 is going to be 8, 8, and C1 is going to be 4, 6. What rule did he use to draw the image? Okay, so if we were to draw the image to look at it, we'll do that just because that's always a good first step. May not be necessary. Y, X. Okay, I've drawn my pre-image and I've included my vertices here. So I've labeled my point A, my point B, and my point C, and of course using these coordinates for my vertices. And then he says he translates the figure, so the coordinates of the image are now, here's my new image, right? Here's my image, and I'm going to go ahead, and if we take point A, and I'm going to go ahead and graph these in yellow. So A1 is going to be 5, 1. So that is going to be 1, 2, 3, 4, 5, 1. Okay. That is going to be A, and then B is going to be 8, 8, which is going to be 8, 8. So I did just have to make some corrections on my drawing because I had written the coordinate down incorrectly. But as you can see, here's my image, and then my pre-image, and then my new image. And then if we look at just what's going on here, we can say that if we go from A to A1, it looks like I am going to actually go up 5 units, right? So it went from negative 4 to 1, that's up 5 units. And then it turns out that when I do my x value, I go 1, 2, I went back 2. So my x values went minus 2, my y values went plus 5. It looks like my rule might be something along x, y, and then it is x minus 2, and then y plus 5 is going to be that rule that I need to draw my new image, because my x values seem to decrease by 2 and my y values increase by 5. Now, could you do that mathematically without drawing a picture? So if I take those 2 points, I can see that like when we talk about a number line, we always want to say, hey, where am I at now? And then I subtract where I started from to figure out what the total distance was. So I could turn around and say that, well, if I end up at 5, I can take 5 minus, and I subtract where I started from on the x-axis, which would be 5 minus 7. So my x values changed negative 2. So I'm looking at x was negative 2. Now on the other side, my y values, I end up at 1 minus negative 4, which is going to be 1 plus 4, and equals 5, so it looks like y is plus 5. And sure enough that those two calculations do match up. I do have, algebraically, the information that I was able to look at from the graph. So there is looking at translations and continuing with these transformations and now rigid transformations.